All right, so if you're on the lesson plan, you clicked on this link, which is the video you're watching. Come up here and click on the first one, which is plate motion. It says step up. All right, now when you're doing this pops up. If this doesn't pop up, just do as the directions on the screen say. It might have you like right click and allow and enable and all this. Just go ahead with it. Don't worry, your computer isn't going to come down with a problem. All right, once you're here, it says pick a direction for plate 1 to move. So plate 1, we're going to click this right there, and it's going to go this way. You can see. Now, let's see plates over time. So what you're going to do is right here, you're going to pick a time and have it go to 200 million years. And then you're going to have it hit run. Now you're going to see these bubbles start to form there. Yay! Okay, right? Also too, that's getting kind of fat, that crust. This takes a lot of time. Those bubbles are actually mountains forming. Because what's happening is these two plates are starting to squish together, which means the mountains go up and the plate actually gets thicker and fatter down there. So what if two oceanic plates collide? Then you're going to have islands form. So, all right. Oh, let's see. Let's click on that one. Convergent boundaries. Oh, let's go with this one. Pick a time. We're going to click on 200 million years, and we're going to hit run right there. Oh, wow. We still got like those. Those are earthquakes right there. Oh, my gosh. Look, they're converging. One of them is going down underneath. Oh, gee golly whiz. Look right there. It's like volcanoes and islands are starting to form right there. Oh, and the seashore is getting closer. Wow. Cool beans. And that's after 200 million years. We're going to go for home. And then we're going to hit that, which is divergent. See plates over time. Pick time. 20 million years. We're going to hit run. Oh, wow, look at all those earthquakes. Look at it be divergent. Those two plates are being drawn apart like that. Now, as that's happening, here we go. Yep, water forms just like that. Oceanic plate, a lithosphere is forming. Dang, and we got volcanoes there. Good. Okay, now we're going to go for home. We're going to see this one right here. See plates over time. Pick time. Once again, we're going 200 million years. Hit and run. Oh, wow. They're starting to shear. Starting to form apart. Good. They call this transform. The thing about this that you'll see is it creates an abandoned river. So instead of the water flowing this way, it now flows this way. This happens with a transform or shear boundary. Good. All right, we're going to go for home. Now for this one, we're going to click extension, bent plate, like this. First one we're going to do is this one here, which is a spreading bend, like that. See plates over time, pick time, 200 million, hit run, earthquakes all around. Hey, what do you know? This one's starting to go this way, that one's starting to go that way, right? Like that. Like that. See that river? Oh, that river's now abandoned. It's dead. Oh, it created a lake. Cool. Oh my gosh. Look right there. It created a river. Sweet. Okay. Good. Now we're going to go home. Extension plates again. Go up to here. See plates over time. Pick time. 200 million. Hit run. Oh, look at those. Those plates are colliding. They're going this way. Wow, look, mountains are starting to form there. Ooh, that river's starting to twist again. Betcha we end up with an abandoned river. Hey, what do you know? Abandoned river turned to brown. Now the river's going this way because it's easier. Good. That's what we got. All right. Hit home. So that's what you need out of this software. Now the second software, that one's a little bit more difficult. This is back on the lesson plan. We hit this. Click on that. It's going to ask you right here to download it. Go for it. Down here, you're going to need to hit open when done. Hit keep. Hey, what do you know? It started right up, right here. I'm going to make it big like this. Good. All right. Now, what we're going to do is over here on the lesson plan, you see where it says directions and questions? We're going to click on that and open that up. And it should look like this. It says PhET Tectonics, PhET Simulation. These are not questions you have to answer. This is something I stole from a teacher, and it's one of those things I think by you just going through the process, it'll help you out. Describe the differences between oceanic and continental crust, including their respective properties, density, composition, temperature, and thickness. So, predict how changes in composition and temperature change over crust density and buoyancy. And then predict tectonic movement based upon compositional and physical characteristics of each plate. Part 1, describing differences between oceanic and continental plates. Open the plate tectonic simulation, which is already opened. Play with both tabs for about 5 minutes. It says down here, the crust tab. Look at the picture on the right. Which type of crust is hotter at its base? Whee! Continental oceanic crust. So if you look at the thermometer right here, it is not as high on the ocean, but for the continental, it's higher. So the continental crust is hotter. Why would the base of that type of crust be hotter? Possibly because it's closer to the core. All right, but you didn't hear that from me. Let's see what the next part says. Drag the density meter over the middle of the crust that is not labeled and drop it in the light gray area. Use the adjustment in the My Crust box to try the following. Okay, so right over here, this is what they're talking about. The part here where it says crust and there. So here's your density meter. We're going to move the density meter to right there. Okay? Then it says what happens when you add more iron. So what we're going to do is we're going to go to composition. We're going to add more iron. Oh my gosh, the density got higher. All right? If you change the composition by adding more silica, what happens? Goes far right. Oh, and the density goes down. All right? So more iron, more dense. More silica, less dense. Click, and this says here now, click the yellow Reset All button at the bottom. Here we go. Clicking the Reset All button. All right, now put the density meter on the middle crust again. If you add the heat to the crust, what happens to the density of the material? What happens to the density of the material if you make the crust cooler by taking away the heat? All right, so here's what we're going to do. We're going to move this density thingamajiggy on up there. Now heat. We're going to make it hotter. It decreases the density. And now we're going to make it colder. Hey, it increases the density. Not by a lot, but it does it. So got that one figured out. All right, did that. Now number 4. Use the density meter to compare the oceanic and continental crust. Which is more dense? And why might it be more dense? Look back at your results from part C. Okay. So we're comparing the crust over here. And there's the crust for the oceanic. Now, wow, the crust for the continental crust is less dense. I think it's less dense because all that ocean water is sitting on top and pressing down on the oceanic crust, which makes it more dense. All right. So for number 5, list all the ways you can find to change the oceanic crust into continental crust using the sliders. So just about anything that's going to raise this on up. So if I go over this way for thickness and I go, hey, gonna make it thick, okay? Getting it towards continental crust. Composition, we're gonna want it more silica, that way it raises up. And as far as temperature, we're gonna make it warm too. So basically these sliders, we're gonna want it warm, silica, and thick. And that's gonna make it more continental crust, as opposed to, if you make it thin crust, oh, right there, it's underwater. Or if you make the composition more iron. Dang. Yep. And if you make it cold, forget about it. All right. Look, it's under the sea right there. Good. All right, back to this. 3 main types of plate boundaries. You got spreading, where they pull apart, affects constructive, ridge tilt, volcanic activity, yes. Convergent, where they go together. It's destructive, it's trench, and it involves volcanoes, yes. And then you got transform, which is where they just shear back and forth like that. That's conservative, no major effect, and no volcanic activity. All right, let's see what we got down here for questions. Plate motion tab. So up here, instead of it being on crust, we're going to hit plate motion. Good. Now it says, always view both, show labels, and show seawater. So if I go down here, we're going to go with both, show labels, show, and doesn't give us show seawater. It will though if we do this. Let's put continental crust up there. And let's put young oceanic crust right there. Good. Now we get show seawater. Good. All right. So we did all, oh, we didn't do manual mode. Click it over onto manual mode, which is right here. Good. Note, to see the same action happen again, click rewind. To start over, click new crust. Drag one oceanic crust, either young or old, we did that, and one continental crust onto the screen. Drag the plate in the direction of the green arrow. So what we need to do is drag this green arrow and be like, yep, got it moving, got it moving. Oh, wait a minute, look. Oh, dang it. Need like 2 hands for this. See the volcano forming right there? Yeah, that thing's puking. Or erupting. That's more scientific. All right. Let's see what they got for questions here. Draw it? Not really. Type of boundary. That is definitely convergent. What is the effect outcome of this plate movement? It's subduction. All right. That the lithosphere dips underneath the other lithosphere, and then it causes volcanoes to form. All right. Now let's see 2. Example 2. Oh, this is probably where we need to clear it out. So what we need to do right here is just go new crust. Hey, what do you know? All right, so for this one, drag 2 old oceanic crust onto the screen. Drag the plates in the direction of the red arrow. So 2 old oceanic crust. So old crust comes up here. Wow, come on now. Dragging her up there, yep. Some more old oceanic crust. Dragging it up there. Good. Now these red arrows, let's pull them apart. Hey, oh, and there's young oceanic crust forming. As the old moves out, the young comes in. And what do you know? Looks like a volcano. Hey, that's after 35 million years. Sweet. Okay. What's the effect? Oh, and this one is definitely divergent. And what is the effect outcome of this plate movement? Yep, pulls apart, volcano. This thing with all the red down there, I drew that in so you don't have to do that. Okay? Next says, find a way to create a volcano on a continent. All this stuff from here on out is basically you kind of playing around and having fun with it. All right? So try your best with it, and good luck. If you have any questions, email me.